What's up, everyone? This is LeetCode 33, search and rotated sorted array. So there's an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index k, and k is between 1 and the length of the array. Pay attention to the less than equals, right, and less than sign here. Such that the resulting array is nums k plus 1, etc. 0 indexed. I think paying attention to the examples is a good way to understand what this problem is asking you. We're given the array nums after the possible rotation and an integer target. Return the index of target if it is in nums, or -1 if it's not in nums. So yeah, so initially this array is sorted, right, and then it's rotated such at a pivot index, such that, for example, this was all sorted, right, 0 up to 7, right, 0 1 2 3 4 5 6 7, and then it got rotated, meaning at some pivot index, basically, that got chopped off and put to the front of the array, right? And so the ordering is changed now. And so we're given a target, which is a number, and we have to check, does that number exist in nums? If it does, return what index it exists at. If it doesn't exist, return -1. For example, example 2, the target 3 does not exist in this array, right? There is no 3, so we return -1. 0 does exist, right? But it would be at index 4, right? 0, 1, 2, 4, index 4. Here we have an array of 1. The target is 0, it doesn't exist. Return -1. Now this might seem like an easy problem. Basically, you have an array that's kind of sorted initially. It's kind of jumbled up or rotated, right? And you have to basically find, does target exist in the array? And if it does, return the index. That seems simple enough, but the issue is you have to write an algorithm that is an O log n, right? So you can't do an O of n solution where you basically just do like one pass through and check where the pivot point is, or the pivot index. So it's not that simple. But there are two things that you have to use to your advantage in this problem, and that is that this array is sorted in ascending order, right? So we know it's sorted initially, and we also know that we have to use an O log n solution. So what you have to use here is a binary search, and not always do you have to use a binary search when they ask for an O log n solution, but you should always consider it when they ask for this, because it's kind of like a little hint. This part here, right? They're like little hints. They can mean a lot of things. Doesn't necessarily mean you always have to use a binary search when it tells you that, but you gotta keep that in mind, okay? So this is how we're gonna solve it, right? We're gonna have a left pointer and the right pointer, right? Because again, we're performing a binary search here. So this is our example 1. Let me move this down. Okay, this is example 1. So we're gonna perform a binary search, right? So we're gonna do L plus R divided by 2, right? So L is at index 0, R is 0, 1, 2, 3, 4, 5, 6, right? 6, divide that by 2, 2, 4, 6, so that's 3. And we're gonna take the floor, right? So if it was like a decimal, like 3.2, we would take 3. Because we need to get the index, right? So we don't want a floating point value. So we get this index 3, and that's going to be our midpoint, right? So 0, 1, 2, 3. This is our midpoint. Okay. And so we're going to check, basically, is this midpoint here, is this bigger than the left point, or than the left index, okay? Because that's how we know if it's sorted, right? For this portion, if it's sorted or not, right? And it is, right? Okay. The mid here is bigger than the left index here. So now we need to basically check in this region here, right? We need to check, does the target exist somewhere here, right? So we would do, right, nums of L, right? Nums of L. I'm just going to abbreviate it like this just so I can write faster, right? Nums of L, target less than or equal to nums of mid. Okay, that's how we're going to check it programmatically. Is target basically between this point here and this point here? Does target exist somewhere in there? And the answer is no, right? Because 0, we have 4 and 7. Obviously, 0 can't exist between 4 and 7. So what we would do here is we would take the left index, put it to mid plus 1, okay? And now we're going to have to calculate the, we're going to have to calculate the midpoint again, right? So this would be 0, 1, 2, 3, 4. So we would have 4, right, plus 6. Take the floor of that by 2, right? So 4 plus 6 is 7, 8, 9, 10. 10 divided by 2 is 5. So our midpoint should be 5, right? So our midpoint should be right here. And we're going to have to do the same, right? Is the midpoint greater than the left pointer? Yes, it is. Okay. So then we check this boundary here. Does the target exist in here? Yes, actually. Because the target's right there. And so what we would do, if the target does exist, we would shift the right pointer over to mid minus 1, right? And so then when we check again, for our final step, we would get the actual pivot index, which is this index here, right? So that's basically how our algorithm's going to work. I can do this again really quickly. This is a different problem. It looked really similar. So we have this, right? So we're going to calculate the midpoint again. So we would do 0 plus 0 plus 1, 2, 3, 4, 5, 6, right? So we'd get 3. And so our midpoint 0, 1, 2, 3. Midpoint is right here. Okay. Now we would check, is this midpoint bigger than this? And I'm talking about the value, not the index, obviously. Is this midpoint bigger than the left pointer? Yes, it is. So let's check in this boundary, right? Does target exist in this boundary? No, it doesn't. So what that means is that potentially it must exist over here somewhere, right? So we need to check that. And so what we would do, again, is we would move the pointer over. And the reason we do it like this, obviously, is because, again, this is pivoted, right? Like, it's not sorted properly, right? Because it got pivoted at some index. And then we would do the same, right? We would get the midpoint, like, because this is the same array as the first example, except the target is different. So now we would check the midpoint, right, and the left pointer, right? Are they sorted? Or is the midpoint, sorry, bigger than the left pointer? Yes, it is. And then because that's the case, I'm just trying to Control Z. So the midpoint is bigger than the left pointer. Nice. Now let's check. Does target exist in this region? No, it doesn't. So what would we do in that case? We would have to shift the left pointer over to mid plus 1, right? And then we're here, right? And it doesn't exist, right? So in our final step, we would shift the left pointer over again, right? And because, well, actually at this point, the midpoint, I'll show you what we do. So the midpoint would be here, and we would check, is mid bigger than or greater than or equal to the nums of L? It is, right? Because they're at the same spot. But we would check, okay, is target between this and this? Well, no, because target is 3, and it's not between 2 and 2. So we would have to move the left pointer over again, right? We move the left pointer over, but now we have a point where the left pointer and the right pointers, use a different color, where the left pointer and the right pointer are not in the same, well, the left pointer is greater than the right pointer. So we would have a problem, we would exit. And again, remember, if we cannot find target and nums, we return -1. So example 2, well, what do you know? We should return -1, right? And this right here, obviously, very simple example, but you would just basically check, get the midpoint, which would be this, and right, the left pointer and the right pointer pointing to the same place, right? The left pointer would move over, it would be greater than the right pointer, and we never found target, so we return -1. Okay, this problem I don't think is too difficult once you kind of visualize it, but that's kind of why I spent some time visualizing it rather than just going straight into the code. I think this problem is way easier to understand visually first before you write any code, okay? So let's get the left pointers and the right pointers and set those up. So we're going to say L is equal to 0, R is equal to length nums minus 1, right? And we're going to say while the left pointer is less than or equal to the right pointer, we're going to get the midpoint, right? So we're going to do L plus R, take the floor, right? Find the midpoint. And first of all, what we're going to do is if this midpoint is equal to target, we can just return the index, right? Because we found what we're looking for. Otherwise, right, if the midpoint is greater than the left pointer, where the left pointer is, we know this is sorted. So now we need to check if target exists in that boundary, right? So this is where we would do nums of L, right? Less than or equal to target, and then equal to nums of mid. If the target exists in that boundaries, we can shift the left pointer over. Or sorry, not the left pointer, the right pointer over. So we do R is equal to mid minus 1. Else, in this else statement is basically where target exists outside of that boundary. So we know that we can just move the left pointer over because that boundary doesn't matter at that point. So we would say L is equal to mid plus 1, right? This else statement is where nums of L is not less than or equal to mid, right? Which means that when we get to the midpoint, that point is actually less than, right? When we get to the midpoint, like here, that point is actually less than what's over here. In which case we'd have to do something a little bit differently, right? We would basically have to check, okay, let's check the right portion and see if target exists there. And if it doesn't, if it does, we can handle that appropriately. Otherwise, let's actually just consider what's on the left, right? So the way we would do this is we would just basically do what we do up here, right? Except we're doing it for the right portion, right? So we're going to say nums of R is less than target. Or sorry, not nums of R, nums of mid, right? Does target exist in the boundary between the midpoint and the right pointer? That's what we're doing, right? So we would say nums of R. And if it does, then that means target exists in the right portion, so we have to move the left pointer over. So we do L is equal to mid plus 1. Else, that means target is on the other section, which would mean the right pointer actually gets moved over. So we would do R is equal to mid minus 1. Okay. Now, if we exit this while loop and we never return in this if statement up here, it means we could never find target in nums. And in that case, we would just return -1, right? Okay. Yeah, like I said, I think this problem is easy when you visualize it. That's why, like, I think you should make sure you can make sure you know what we're actually doing visually, right? It'll make more sense. But yeah, this problem, tiny bit hard, honestly, to come up with on your own. The binary search, because you have a lot of conditions to check, but you're just basically checking if it's sorted between the midpoint and left pointer. And if it is, let's check that boundary. Otherwise, let's check the mid and the right section, because that should be sorted, right? In which case, it should be okay. So anyways, that's how we handle our different conditions. I hope this helped, and I'll see you in the next one.